Today we are starting section 1.3. We are still dealing with solving equations. This time our equations will have a variable on both sides of the equal sign. All right, on these warm-ups, we already said we are not solving because there is no equal sign. We are simplifying. So on number 1, what can I do to simplify? Combine like terms. What can be combined? The x's. We have a positive 2x and a negative 2x. Dominic, what happens?
Which leaves us no x at all.
Good. So what's left?
Just 3.
Just 3. Positive and negative 2x cancel each other out. We just have a 3. On number 2, what's the first thing I can do to simplify? Liam? I cannot do that yet. What do I need to do first, Hunter?
Distribute.
We need to distribute first. We have to get rid of those parentheses and distribute before we can combine like terms. So when we distribute, what do we get?
8t plus 12.
8t plus 12. We still have what on the end?
Negative 4t.
Negative 4t. Now we can combine like terms.
Yeah. 4t plus 12.
Good. When we combine the positive 8t with the minus 4t, we end up with 4t plus 12. Number 3, what can we do to simplify? Combine like terms. What combines?
Negative 2w plus 2w.
The w's combine. What happens to them?
They cancel out.
What are we left with?
55.
Good. We are left with 55 as our final answer. Number 4, what's happening first? Distribute. We got to get rid of those parentheses. We are just distributing the 5. And that's the first thing that happens, which means we have an 8 plus out in front. Do not add the 8 to the 5 and then distribute. That will not come out the same. When we distribute the 5 into the parentheses, what do we get?
5x minus 5.
Very good. 5x minus 5. We still have what else on the end there?
Negative x.
All right, now we're ready to combine like terms. Who can tell me what they want to combine? Hunter?
5x and negative 1x.
Good. What does that give me?
1x.
Very good. Who else can tell me what I could combine? Annabelle? The 8 and the 5, but we got to make sure the 5 is negative. There's a minus sign in front of that 5. We got to treat it like a negative. When we combine them, what do we get?
3.
Positive 3, so a plus 3 on there. Be careful with your integers. All right, on number 5, what are we combining? The u's. When I combine the u's, what happens?
0.
Cancel out. We're left with 22. Our steps to solve a linear equation. The first thing we do is use the distributive property if we need to get rid of grouping symbols like parentheses. After that, we simplify. I would maybe make a note that we simplify by combining like terms. After that, use inverse operations to get the variable on one side and get constants on the other side. So variables on one side, constants on the other side. The only way to do that is using inverse operations. The last two steps are pretty familiar. Isolate the variable, get it alone, and then we should be checking our solutions on some of these more complex problems. Again, I would not write this slide down word for word, especially these first couple things can get shortened real quick. First step, distributive property. Next, simplify by combining like terms. Okay, variable on one side, constants on the other side. Let's get into our examples. When we start these problems, the first things we should be checking for are distributive property and combining like terms. Can we do that on either of these? No. There's nothing to distribute. There's nothing to combine right now on example 1 or on example 2. We do have two different a terms, but are they on the same side of the equation?
No.
No. So we cannot combine them unless they're on the same side. So we're trying to force this a term to go with the other one. We want it to zero out from this side so that it can go to the other one. How are we going to zero out a positive 2a, Liam? Nope. Hunter? Subtraction. If we want it to become a 0, we have to subtract it. That's why on the warm-ups we had so many where when we combined like terms, the variable zeroed out. That's what we're doing with that. But if we do it to one side, we better do it to the other side. This way, all of our a's are going to be on the left side, and we won't have any a's on the right side anymore. So now I can combine the 8a minus 2a to give me 6a, and now it is equal to 30. Questions about that step? We need to regroup so that all of our variables are on one side, constants are on the other. Now what do we need to do to get a alone? This goes back to what we were learning last week. We divide both sides by 6. We get a equals 5. Now we might not check every single one of the problems that we do today during the notes just because of time, but we will check some of them so that you can see how we check it. If we are going to check it, we have to go back to the original problem and plug in our a. So, put a big bar. So yes, so we put 8 times 5 instead of an a equals 2 times 5 plus 30. So I rewrote the original problem, but instead of a's, I put the 5's. Now we're just simplifying both sides and seeing if they come out to equal the same thing. What's 8 times 5? What's 2 times 5? What's 10 plus 30? So does 40 equal 40? Yes, so I give it a check mark. Yes, it worked out. It was correct. So if it asks you to check, that's what you do. You're not doing things to both sides of the equation. You're not rearranging it. You're just plugging in and simplifying to see if they come out to equal each other. All right, on number 2, do we have any distributive property?
No.
Do we have any combined like terms?
No.
We need all of our variables to be together. So what do you want to do to both sides? Add 6t, good. We can add 6t on both sides. That'll give us all the t's on one side, anything without a t on the other side. All right, if I take 4t plus 6t, what do I get? 10t equals, last step to solve, divide, t equals 5. Again, we could check that by plugging 5 back into the original problem.
You subtract 4x from both sides.
Good. We got to get all the x's together. Subtract 4x on both sides. That leaves me with what? 2x equals?
18.
Last step.
Divided by
X equals 9. All right, number 4 is a little bit different. What do we need to do first on number 4?
Distribute.
Very good. This one brings in the distributive property that we were supposed to be checking for. When we distribute, what do we get?
3W plus 3.
3W plus 3 equals 2W. Now on this one, we want all the W's on one side and anything without a W on the other side.
minus subtract 3W. Yeah.
Okay, there are multiple ways to do this. Probably the most direct way is to subtract the 3W from both sides. If you wanted to move the 2W, I'll show that method in just a minute. When we subtract 3W from both sides, be careful with what's left.
3 equals
Very good. 3 equals negative 1W. If you want to put the 1 in front of the W, you can. You do not have to. Divide both sides by a negative 1. And what do we get for W?
W equals 3.
Negative.
Negative 3. We got a positive 3 divided by a negative 1. Our answer is negative 3. Now, if you wanted to do it the other way, I'll show that in the middle here with a different color. If you started it after distributing, some people like to take the big minus the small, and that's fine. So some people would like to subtract 2W from both sides. If we take 3W minus 2W, what do we get? 1W. We still have a plus 3. What does it equal?
3W.
Nothing, which in math we call
0.
0. We would have to put a number there. That's the big mistake that people make when they try to do it that way. You've got to put a number there. And then to get W alone, what would we do?
minus 3.
Good. Subtract the 3. And again, we get the same answer that we just got. Those are the same answer. We just got it 2 different ways. I don't care which way you do it, as long as you show me all of your work. What's the first thing I need to do on number 5? Distribute. We distribute the 4 into the parentheses to get us what? 4R minus what? 36. Everything else stays the same. The plus 2 equals 12R plus 14. All of that just stays the same. Now what can we do?
Combine.
Very good. We need to combine like terms. We haven't seen one where we had to distribute and combine yet. What can combine?
36 and 2. Negative 36 and
Very good. Anything that's on the same side of the equal sign that are like terms can combine. So we combine minus 36 plus 2. What does that give me?
2. Negative 34.
Negative 34. You need to be careful with your integers. If you were to put 4R minus 38 there, it would throw off the whole rest of your problem. So now comes the time where we've distributed, we've combined like terms. We need to get variables on one side, things without variables on the other side. So you have to choose which side's getting the variables, which side's getting the constants. Now, some people like to move their smaller variable if you have to move both anyway. So a lot of people would recommend moving the 4R. How would we get rid of 4R? Minus 4R. And if we do that on the left, we have to do it on the right. Gotta happen on both sides. So on the left, what do I still have?
Negative 34.
Negative 34 equals 12R minus 4R. Gives me 8R. We still have a plus 14 behind the 8R. Yep. Yep, now we got to subtract the 14. We're trying to get r alone. We saw problems that looked like this stage last week. When we subtract 14 from both sides, what do we get on the left? Negative 48. Good. Be careful with your operations with integers. On the right side, we still have that 8r. Last step is to divide by 8. And that gives me r equals. Careful.
Negative 6.
-6. Watch your signs. That one was a long problem. Lots of work to show. I expect to see it all. Questions about number 5? Okay, number 6. Do we have to distribute? Do we need to combine like terms? No. There's nothing on the same side of the equation that can combine. We have nothing to distribute, nothing to combine. So we need to get variables on one side, constants on the other side. What do you want to move?
-2x.
I like that decision. In order to get rid of a negative 2x or zero it out, what do I have to do?
Add 2x.
Very good. We add 2x to force that to zero out. But if I do it on one side, I better do it on the other side. Make sure that when you do that, you are adding it to the other x term. Do not add 2 to the 89. That is the wrong thing to do. All right, the 89 hasn't changed. It's still hanging out front. We have a positive x plus 2x. What does that give me?
3x.
A positive 3x equals 2 because the x's on that side zeroed out.
-8.
Very good. We need to move that other constant. We do it to one side, we do it to the other. That gives me 3x equals
-87.
-87. Last step. Divide by 3. What do we get for x? -29. Very good. All right, we've seen problems sort of similar to this before, where we've got a big fraction bar. We don't have anything to distribute. We don't have any like terms to combine. So our first goal is going to be able to get rid of the big fraction bar. Very good. In order to do that, we multiply both sides by that denominator. Do it to one side, do it to the other side. Okay, what happens with these 3's?
Cancel out.
They cancel out. So what do I still have on the left side?
X minus 2.
X minus 2. Don't do anything with the 3 and what's in the top. The only reason the 3 is there is to cancel out with the bottom. Equals, what do I have on the other side?
X times 3.
X times 3, how do we write that usually?
X over. Yeah.
3x. Remember, multiplication works the same frontwards and backwards. So instead of x times 3, just write it as 3x. We need all the x's to be together.
Plus 2. No.
Subtract x.
Technically, you could add 2 to both sides. That's not necessarily a wrong thing to do. The quicker thing to do is going to be to subtract x on both sides. So what are we left with on the left side? A -2. Make sure you keep that sign. -2 equals 2x. Last step. Careful. Divide by what? Good. Divide by whatever is right next to the x. In this case, that's a positive 2. Negative 2 divided by 2 leaves us with a negative 1. X equals negative 1. Let's go ahead and check number 7. Let's do a check step. I'll do it in red. When we check, we plug back into any x in the original problem. Okay. So anything that I wrote in the purple color in this case is not part of my check. We plug it straight into the original printed problem. So instead of x's, I put a negative 1 in place. Now, the right side is already simplified. So we just leave that side alone. On the left side, negative 1 minus 2 gives me what? Negative 3. It's still getting divided by 3. What's negative 3 divided by 3? Negative 1. Does negative 1 equal 1?
Yes.
Yes, so I got it right. I checked it. So if they're asking you to check, you plug back in your answer to the original problem before you did any work. Janaya, what'd you do on this one? So we multiply by 9 on both sides. I agree with that. What happens to the 9s on the left?
Cancel out.
They cancel out. So what do we have left?
8 plus x equals 9.
Very good. So we would rewrite x times 9 as 9x so that it's how we're familiar with seeing it. What else should we do?
Minus x.
Good. When we subtract x on both sides, what do we have?
8
Good. 8 equals 8x. Last step.
divided by 8.
Divide by 8. X equals
1.
1. If you leave it as 1 equals x, because that's kind of how the problem was set up, that's also fine. X equals 1, 1 equals x. Same thing. On number 9, there is a trick to making this whole problem a little bit easier from the very beginning. Anybody know what it is before I give it away? Janaya, do you think you know it?
I think.
What?
Are you supposed to do we use the rule when we
Do we what?
do we use the rule when we put it in
We could use that rule later in the problem. It's related to that rule. The whole idea is to get rid of those fractions. And we can do that by multiplying everything on both sides by the denominator. So what is my denominator? 5. So we are going to multiply everything, all of it, including the 4, multiplied by 5. Now I want you to be careful when you do that. If you take 3/5 x times 5, what happens to those 5s?
Cancel out.
And what are you left with? 3x equals 4 times 5 should be the easiest part. 20 minus, if we take 8/5 x times 5, what happens to the 5s? They cancel out, and what are we left with? 8x. That step is not completely necessary. It is possible to do this problem without doing that. However, most students don't like working with fractions, so if you get rid of the fractions right away, makes your life a little bit easier. Questions about how we did that? Okay, the important part is that it has to happen to every term, even ones that are not fractions. You could subtract 3x, but it's not what I would do. I would add the 8x so that the 20 just stays alone over there. Again, there are multiple correct ways to do these problems. So as long as you're showing your work and you're doing it valid, mathematically correct, that's fine. 3x plus 8x. 11x equals 20. Last step. Divide by 11. Is this going to divide nicely?
No.
No, it is not. Will that fraction simplify?
No.
No, so we'll leave it alone. 20 over 11. Just leave it as a simplified improper fraction. Don't even mess with the decimal point. The only time I would ever mess with decimal points is if it's like a 0.5 or 0.25, something real short and simple. If it's not short and simple like that, don't even bother. Number 10, also an interesting situation. We need all the W's together. So what do you want to do to both sides? Liam? I agree we could add 17W to both sides in order to get all the W's together. But what does that leave me with on the left?
It canceled out.
It does cancel out. So what number can I put there?
0.
A 0. You have to put a number there. It's got to be something.
18W.
0 equals 18W.
Divided by 18.
Get W alone by dividing. Zero divided by 18 is? 0.
Oh, I thought I was going stupid the rest of it.
Questions, concerns? I should still see work. Even if 0 is your answer, that's fine. I should still see how you got there.